Hi, and welcome to another episode of Science in Context. I'm Dr. Tom Rawson, and I'm joined this week by Dr. Juliette Unwin. She's going to talk to us about a recent review of epidemiological parameters and models for Ebola virus disease. So, Etty, tell us about your review, perhaps starting with what is a review?
An academic review is about extracting and analysing scientific papers to build up a picture of what they're saying. This new one investigates epidemiological parameters and models regarding Ebola virus disease. In total, we extracted 1,280 parameters and 295 models from 522 papers about Ebola. One of the parameters that epidemiologists are most interested in is a basic reproduction number, or the number of secondary cases a primary case would infect in a fully susceptible population. What we saw for Ebola is these estimates varied a lot, and the mean values ranged everywhere from 0.29 to 10 for the West African outbreak, which was the largest previous outbreak. Estimates of the case-fatality ratio were highly context-specific, but on average 57.8%, and when weighted according to sample size was 64.6%. Meta-analyses of epidemiological delays, such as the incubation period and the time from onset to death of recovery, suggested a significant difference between the different species of Ebola.
So when there's new Ebola outbreaks, you're going to want to use different parameters depending on the species of Ebola, and all that is contained within this database that you've created. Is that right?
Exactly. However, 92% of the total number of parameters extracted were from the Zaire species, so there's a critical shortage of evidence about the others.
That's parameters. What did you learn about models, different types of models used for Ebola?
Models have historically been used to inform Ebola response, and one of the main motivations for this work was to provide all of the available parameters for these models from the literature and to see what others have done. We wanted to be able to provide the most up-to-date evidence to parameterize our models. Now, reproducibility is an important part of any modelling study. Unfortunately, only 13% mentioned publicly available code, and actually we could only access the code for 8%. This is a real hindrance to a quick response. However, with this review, we've made these meta-analyses freely available to the scientific community, so that when the next outbreak appears, scientists will have all the knowledge that's come before at their fingertips to help inform their response.